Hello students, in this video I am going to discuss about the characteristics and excitation table of SR flip-flop. So for making this characteristics table, first we should know the truth table of SR flip-flop. So from the truth table only is possible to design this characteristics table, right? So the truth table of SR flip-flop I explained in my previous video. So go and refer it. So it is nothing but if the inputs S and R is 0, 0, then the next state will be the previous state. Where that input is 0, 1 conditions, our next state is SR flip-flop, next state is reset state. And input 1, 0 condition, the next state is a set state, and 1, 1 condition is a invalid state or forbidden state. So let's see how the characteristics table is created from this truth table, right? The input of the characteristics table is our present input. So present input is nothing but S and R, and the previous output or past output, which is nothing but Qn. So these three variables are considered as the input of this characteristics table, right? And Qn plus 1 is nothing but is a next state, which can be considered as an output variable. So in these three input variables, the three combination can make the 8 possibilities, which is nothing but 0, 0 to 111, right? So from this truth table, we know that input 0, 0, the next state is our previous state, which means Qn. So we just apply this concept to here, right? 0, 0, input is 0, 0, then next state will be the Qn, right? So Qn is equal 0, so the next state also 0. The second combination also input 0, 0, so the next state will be the previous state. So previous state is here 1, right? So the 1 will be the next state. Then third possibility is input 0, 1. So 0, 1 condition, that next state will be 0, reset state. So here 0, 1 condition, the next state is reset state. This also 0, 1 combination, so next state will be the reset state. So in this input conditions, our past output, it may be 0 or 1, not a problem, right? The next state will be the reset state. So likewise 1, 0 combination. So input is 1, 0. The next state is set state 1, which means 1. So 1, 0, 1, 0. Both combinations are 1, 0. So our next state will be the set state, which means 1. The past output, it may be 0 or 1. No issues, not issues. Our next state will be the set state. And the last condition is 1, 1 input combination, which provide the invalid state x. So here the next state is x, right? So this is the method to make a characteristics table of flip-flops, right? So next, characteristics equations, which is nothing but the output variable Qn plus 1. So using K-map, it is easy to find the characteristics equations. So for the K-map, the inputs are totally 3 variables. So here we are using 3 variable K-map, right? So the output of the next state is 1 for the condition of 1, and this is for 4. This is for 5, 1, 4, 5, and this don't care output is the combination of 6, and this one is the combination of pattern of 7, right? So we have to substitute in this K-map. So this position is 0, this position is 1, so you have to place 1 at 1 position, and 2, 3. So 2, 3 having 0, 0. Then 4, 4th pattern having 1, so 1, and 5th pattern having 1, and 6th, 7th pattern having don't care. Next one is grouping. Here the don't care also possible to grouping with adjacent ones. So here we have to group at a quad cells, and this one is grouping with the adjacent cells for in a overlapping manner, right? So there are 2 groupings. So from this grouping we can write that logical equations. So for in this group here both are cancels, right? In this grouping is there. So first grouping, let's consider this is the first grouping. So in this row wise different variables, so it cancel each other, and column wise it having 0, 1. So 0 is nothing but R, and 1 is Qn. So here you have to make it as R bar, right? And the second grouping, we are having the column is 1, so which is S, and row wise 1, which is S, and column wise it having the 4 columns, so which cancel to each others. So the characteristics equation is Qn plus 1 equal to S plus R bar Qn, right? Next one is excitation table. So excitation table which is used to find the flip-flop input conditions with the known values of past output and next output, right? So excitation table is mainly used to find the flip-flop inputs with the known values of Qn and Qn plus 1. So this excitation table also determined from this characteristics table, right? So let's see in this characteristics table, if Qn plus 1 0 0, right, then SR value is 0 0, right? So in this excitation table the inputs are Qn and Qn plus 1. So the two variable having the four possibilities 0 0 0 1 1 0 1 1. Okay. Here we have to find S and R input of the flip-flop values with these combinations. So which is calculated or identified from this characteristics table. Right? In characteristics table Qn 0, Qn plus 1 0. Then SR value is 0 0. Right? Again, if Qn 0 and Qn plus 1 0 having a two combinations in this row as well as this row. In these two rows, S value is common. In both the rows, S value is 0 and R value is 0 1. So we can write from this two combination, S value is 0 and R value is 0 1. We can write X. Right? Then next pattern is 0 1. So let's check 0 1 pairs in this characteristics table. Qn is 0. Qn plus 1 is 1. So it's not there. So Qn is 1. Sorry, Qn is 0. Qn plus 1. So this pair, this combination 1 thing. And is there any other possibility 0 and 1 in this table? Nothing. So this is only one possibility. So from this Qn 0, Qn plus 1, the corresponding S value is 1 and R value is 0. So for 0, 1 combination, S value is 1, R value is 0. Next we'll check the 1 and 0 for Qn, Kn plus 1 from this characteristics table. So Qn is 1, Qn plus 1 is 0. So this is not possible. So Qn is 1, Qn plus 1 is 0. This only possibility. There is no other combination for this 1 and 0. So in this 1 and 0, S value is 0 and R value is 1. So for 1 and 0 Qn, Kn plus 1 combination, S value is 0, R value is 1, right? And the last possibility is 1 1, right? So in this characteristics table, Qn1 and Qn plus 1 is this pair and also this pair, right? In this two pair, here SR value is 0 0, here SR value is 1 0. So R value is common for both the cases and S value is 0 1. So we can write 0 1 is a X and R value is 0. So this is the excitation table of SR flip-flop, right? So that's all about the excitation table and characteristics table. So in this SR flip-flop has only one major drawback. That is for the condition of S is equal to 1 and R equal to 1, right? S is equal to 1 and R equal to 1 is specifically prohibited because it's an invalid state. It leads to instability. So how this problem is overcome with the help of the other flip-flops like D flip-flop and JK flip-flop. So in the next video, we'll see about the D flip-flop, right?